Thank you for joining me here at SciPy. This talk is about Jupyter at NERSC. I'm Rollin Thomas from Data and Analytics Services at NERSC. NERSC is the National Energy Research Scientific Computing Center. It's located at Lawrence Berkeley National Laboratory, also known as Berkeley Lab in Berkeley, California. I'm really excited to be talking about Jupyter today because making Jupyter work at NERSC has been probably the most fun and exciting part of my job over the past few years. It's really exciting to be helping researchers from all kinds of scientific disciplines do their science through HPC and Jupyter at NERSC. In this talk, I'm going to talk about the development of Jupyter at NERSC, give a guided tour of our Jupyter deployment, and also talk about what engagements we have with our users, user facilities and experiments, other developers, and other HPC centers. I'd like to take just a minute to introduce my collaborators to you. Jupyter at NERSC is a collaborative project extending across two science divisions at Berkeley Lab, NERSC and the Computational Research Division. Myself, Shane, and Kelly are at NERSC, and Shreyas and Matt are over in Computational Research Division. We've had the opportunity to host a number of interns over the past several years to work with us on Jupyter Lab extensions and Jupyter-related projects. So if you happen to be a student who's looking for your next internship, maybe next summer, keep an eye out for job postings from NERSC. We always have one about Jupyter, and we look forward to getting your application. NERSC is the primary scientific computing facility for the U.S. Department of Energy's Office of Science. We are the production science HPC facility for DOE. We operate a supercomputer named Cori. Cori is named after Gertie Cori, a biochemist and the first American woman to win a Nobel Prize in Science. Cori is the first NERSC supercomputer that was designed from the outset to support both simulation and data analysis workloads in a single system. Of course, in terms of science, a supercomputing center isn't all that useful if all it is a building with a giant supercomputer inside it. So there are other things that are important to mention here, including high-performance parallel file systems, a gigantic tape archive for archiving data going back over 40 years, high-performance networking, both to connect systems within the center and connect us to user facilities operated by Department of Energy that are far away, and also a platform for running services that are not HPC oriented, but are nevertheless necessary in order for our users to publish and share their science, such as science gateways and data transfer nodes. NERSC serves the needs of about 7,000 users over 850 projects that are funded through the U.S. Department of Energy's Office of Science. Researchers on these projects are eligible to request accounts and a compute allocation to run jobs, storage, and support services from NERSC. The 6 sub-offices of the Office of Science are listed on the left, and the projects that are funded by those sub-offices are broken down in the pie chart on the right-hand side. NERSC has probably the most diverse scientific workload in the Department of Energy's Office of Science. We're a place where you can run the biggest jobs that you want to run on our system, but by and large, most of the time, people are not doing that. Our job is to provide the most usable supercomputer system in the Department of Energy that is productive for doing science across all of these different areas. Now, over the years, we've noticed demographic shifts in our user base. About 20 years ago, before that, if you were running on an HPC system at NERSC, you were probably running a simulation using Fortran. Around the turn of the century, we started to maybe see Python here and there as a replacement for Perl. And then about 10 years ago, as open source scientific Python libraries, frameworks, and tools became much more productive for users, people were able to develop tools for doing data analysis for data, especially from experimental and observational data facilities, from big user facilities like light sources, particle accelerators, genome sequencers, and so on. So we've shifted our strategy around supporting different programming languages so that we can embrace Python and help users have a productive experience with Python on high-performance computing systems like our supercomputers. There are a number of factors that have contributed to us being able to do this. I list them here, but don't go into them in any great detail. Of course, something that came along with this is Jupyter. If you're unfamiliar with Jupyter yourself, you probably want to give it a shot. The Jupyter ecosystem is a software ecosystem with a number of tools and projects inside of it. The ones that are going to matter the most for this talk are Jupyter Lab and Jupyter Hub. Jupyter is basically an interactive open source web application that lets you create and share documents, which are called notebooks. And these notebooks contain live code, equations, visualizations, narrative text, interactive widgets. But really, Jupyter Notebooks are the platform for data analytics, for machine learning, for deep learning, for scalable analytics frameworks. It's an extremely powerful system, and our users, by and large, have embraced Jupyter as a way of interacting not only with their data, but with our systems at NERSC. It's pretty clear to NERSC that supporting Jupyter is going to be a way to support a lot of different science use cases. It's become an integral part of experimental and observational data science. So here are a number of experiments and facilities which have made Jupyter part of their data analysis ecosystem. More generally, there's a generational shift in how people are doing science through data science, through Jupyter Notebooks. On the left-hand side, there's a picture of Data 8, Foundations of Data Science, taught at UC Berkeley. That class is taught entirely using Jupyter Notebooks. So when those students graduate and they come to NERSC to do their science, they expect to be able to do it using Jupyter Notebooks. So we need to be there to meet them, to meet their needs. Finally, Jupyter is becoming an important tool for reproducibility in science outreach. Notebooks can be shared and re-executed. Of course, on an HPC system, we're kind of struggling with what does that actually mean. It's very common to be able to go to a website and download a notebook that accompanies, say, a science story that you read in the New York Times, and you can take that notebook and you can run it yourself on your own laptop. So these factors, including the last one, which is really about publication and sharing and explaining your science, this makes Jupyter an important part of the future ecosystem at NERSC. Supporting Jupyter users goes back a little bit before the deployment of Cori in late 2015. What happened was we noticed that users were running Jupyter Notebooks on login nodes and trying to connect to those through SSH tunnels, and we thought that looked like a pretty painful process. So we decided to set up a Jupyter Hub instance, which would allow users to authenticate and then spawn notebooks that would allow them to at least see the file system so that they could do visualizations and analytics on the data on the file systems. Over the next several years, we developed the service so that it could spawn notebooks on Cori directly, either on login nodes or in the batch queue system. We've also added more nodes to the Jupyter cluster, basically, on Cori. So right now, there are 3 nodes. There's about to be a 4th added. And we've also expanded access to GPU nodes that are attached to Cori. This slide depicts the growth in the number of users of Jupyter at NERSC over the past couple of years. You can see that this month, even though June is not over yet, we've already set a record for the number of Jupyter users on the system. For context, compare this to the number of SSH-based logins that users do over the same time span, over a month. And there are 2,900 individual users who log in any given month. So this is a pretty respectable fraction of the total number of connections to Cori. Jupyter activities at NERSC are really centered in 3 kind of broad overlapping areas. Jupyter Hub itself, which we manage from NERSC, Jupyter Lab, Jupyter Notebooks, which we extend basically through efforts in the Computational Research Division, and also our engagement efforts, which are internal to the center, external to the center, with our users and with developers. I'm going to give a guided tour of our Jupyter Hub and Jupyter Lab deployment so that you can see what that looks like and tell you a bit about what we did to make it work. But one point that I want to make to underscore here is that support from our management to spend time on software development to support Jupyter at NERSC and in HPC has been essential. So how is Jupyter Hub configured to run at NERSC? First, let's talk about what Jupyter Hub is supposed to do. It's for authenticating users and starting notebooks. Those 2 actions are extremely abstract in the Jupyter Hub architecture, and they can be customized to meet the needs of whoever is running the hub. In our case, we've customized the authenticator module to support multi-factor authentication and talk to NERSC Central Authentication Service. We also, at the point of authentication, are able to talk to that identity service to figure out for each user what systems and queues does this user have access to. And we store that for use later to customize the user's experience. Starting notebooks is handled by a module called a spawner. The spawners that we use are a combination of things that were developed in the open source community. Wrap spawner and batch spawner were created at MSI. We make heavy use of those for starting notebooks inside of batch jobs using our Slurm scheduler, but also for the shared nodes, we use an SSH-based spawner that we developed ourselves. In addition, there's a configuration system which lets you basically configure almost anything. One of the things that we've added is a pre-spawn hook. So just before a notebook is spawned, we check to make sure users are not over file quota so that Jupyter Hub actually works for them. And if there's a problem, they go in, they maybe delete some data or archive some data, and then they're able to start up again. A few other things that the Hub does that are worth mentioning is it launches a proxy that forwards requests to the Hub service by default, but more importantly, it's the thing that connects you and your web browser to your notebook running on our system. It can also manage and interact with services that are running alongside it that can provide features and enhance usability for users. We actually make use of services a lot. They're actually kind of fun to write. The Hub also has a REST API for administration. We use that to keep track of how many users are using Jupyter at any given time, for instance. Our deployment is container-based, but it is not based on Zero to Jupyter Hub yet. I'll get to that in just a second. But one thing that I wanted to mention here is that the modularity, the customizability of Jupyter Hub is one of the things that really attracted us to it. There are other ways to manage login and starting of notebooks. But we really like the modular design, and we also like that there was a very strong, vibrant developer community behind Jupyter Hub. So I mentioned that our Jupyter Hub deployment is a container-based deployment. It's based on Docker containers, but we don't manage the service inside the HPC system, inside of Cori. There's an external container as a service platform that we run at NERSC, which we call Spin. Spin is based on Rancher, which is a commercial management orchestration tool for containers. It has its own scheduler right now, but we're going to be upgrading our deployment of Jupyter Hub to shift over to the Rancher 2 instance that we're running. That's based on Kubernetes, and that might be an opportunity for us to explore something like Jupyter Zero to Jupyter Hub. User-managed services can run in Spin, user-facing services that are stood up by staff, infrastructure services, all of these run in Spin and Docker containers. And most importantly for this talk, that's where our Jupyter Hub deployment is. Here's the nuts and bolts, a diagram of Jupyter Hub at NERSC. The big rectangle on the left is inside a Spin. The small rectangle on the right is the Cray. Behind the front-end reverse proxy of Spin, we have two possible connections. One which goes directly to that proxy that I was mentioning that's part of Jupyter Hub's infrastructure, and then a sorry page when Jupyter Hub is offline for whatever reason. We repoint users at this page to tell them that Jupyter Hub is down so they're not confused about where it is. Here's the hub itself, which is a web application behind the proxy. It's got a Postgres database running in a separate container for maintaining its state. We have another container that runs in NERSC, which allows users to run notebooks if they're not able to spawn notebooks on Cori, say because of maintenance or something like that. And we also have these three other services in these blue rectangles that we run, and I'll show you those during the tour. Now, when you spawn a notebook at NERSC and you do it on Cori, there are a few different ways of doing it. One is to the non-batch nodes, to the login nodes set aside for Jupyter, of which there's 3, maybe 4 by the time you're seeing this talk. Batch administrated CPU compute nodes or batch administrated GPU cluster compute nodes. Okay, so time for the guided tour here. This tour is going to start not at jupyter.nersc.gov, but it's going to be at jupyterstage.nersc.gov. That's the address up here. Jupyter Stage is where we stage a new deployment for Jupyter when we do an upgrade of the version of the hub that we're running. We do a monthly upgrade cycle on Jupyter at NERSC. We try to keep that as non-disruptive as possible. If it's a relatively simple configuration change to the hub, we can do that without disrupting our users' workflows because they're talking through that front-end proxy, and quietly in the background, the hub just recycles and gets updated. We've customized the authenticator for the login page here, and we've also customized the login template to support multi-factor authentication. So a user can enter their username, password, and their one-time password this way. Now, if you happen to be a Jupyter Hub user, you're probably used to authenticating and then popping directly into your notebook. It's possible for users to hop directly to their notebook if they want to, if they just have the URL for their notebook. But if you're just logging in, the first thing that happens at NERSC is that you're presented with the console page. The console page is kind of the jumping off point for where you're going to spawn your notebook today. There are a number of different systems that you may have access to and a number of different configurations on those systems that will work for you. The arrangement of these buttons and exactly which buttons a user gets to see is determined basically by permissions or access control that we're able to query our identity management service for. So since I'm a staff member, I have access to the test system, which is Gertie. That's where we test all of our software before we deploy it onto Quarry. An ordinary user, a non-staff user, wouldn't see that row at all. Most users see 2 or 3 buttons, the Cori and the Spin shared CPU node buttons. That's where most people spawn their notebooks. By and large, they're doing it on Cori. Users that have access to the GPU cluster, who've been granted access to that, see another button for launching GPU-based notebooks. Over here, these are notebooks that start up in the batch queues, either on Gertie or on Cori. And here's one that allows you to configure what the batch job looks like when you submit it. The rest of these are preset, and they use defaults, again, based on information from the identity service. One of the new features in the latest version of Jupyter Hub is this services dropdown. I mentioned services before. And we run 2 services, one of which we developed ourselves to enable communication with our users, and another one that we've just incorporated that facilitates sharing. So I'll start by showing you this announcement service, which is something that we cooked up here at NERSC to help us post little advisories about what's going on with Jupyter for our users. So I'll say something like Jupyter has a maintenance Friday at 5 p.m. An administrator can post that message. An ordinary user doesn't have access to this text field here. What happens once you've submitted that message is that it then gets posted to all the pages on the hub. So here it is on the administration page, on the home page. And you can unpost, if you're the administrator again, the message by just submitting a blank message. So we found this handy to give users a heads up without having to go through our whole message of the day system at NERSC. It's not a replacement for the center-wide message of the day, but it does provide Jupyter-specific information when we need to do that. The next service that I want to show you is NBViewer. You may already know about NBViewer as a way to render and share Jupyter notebooks. We started experimenting with NBViewer and we're going to deploy it this month. At the instigation of the user facilities that were interested in ways of producing canned notebooks for their users so that the users could kind of fill in the variables that were represented, which were important, like the path to their data files or parameters or settings or whatever that were needed, and then users could just run with that. So the way that this works is that you're able to paste in the URL or the path, in some cases, to an existing notebook somewhere on the web. And so I'll pick one here, and then you click go. And what it first does is, if it happens to be in a GitHub repository, you can browse through that repository to find whatever notebook it is you're interested in. And then first thing it does is it will render that notebook for you as static HTML. Right, so you can look at this as a gallery of pre-created notebooks that you maybe want to use for your analysis. What we did was we worked with some collaborators at Brookhaven to add the capability of cloning the notebook into your home directory. So that's what this button does here. So I'm going to click that. And what that's going to do is start up my notebook server and run this notebook and the associated kernel that goes along with it. And there we go. So here's the notebook. It's ready for us to use. We have the kernel for it, and so we would be able to just run this right here. While we're now in Jupyter Lab, there are a number of features that I'd like to show you. One of the problems that we had when we first started running Jupyter Lab at NERSC was that the file browser was actually not really designed, I would say, with the broad and deep kind of parallel file systems, massive file systems that we have at NERSC. So users were finding it very easy to, first off, get lost on the file system and then have a really hard time getting back to, say, their home directory. It was just a lot of clicks to get back to their home directory when they're used to just typing CD, say, at the command line. So we developed the Jupyter Hub Favorites lab extension, and we've installed that for all of our users. And we pre-configure it so that their home directory and Scratch directories are there already. Users can add whatever paths they want to their list of favorites by, say, clicking on a directory here, changing to that directory, and then clicking this star here. So you can see it appears in the list. And if they want to remove it, they can simply right-click on the name of that path and click Remove Favorite. So this offers a really single-click way to get to your favorite places. It's kind of a list of bookmarks on our file system. And after we deployed that, we heard almost no complaints about getting lost on the file system. A couple other things that we helped out with, especially around file system navigation, was adding paths to the recently opened list of things, and then the ability to directly open a directory through the open path feature. At NERSC, we have a multi-user installation of Jupyter Lab, and in that multi-user installation, we have a number of preset kernels. Actually, here you're seeing a combination of preset kernels and then kernels that I've developed while trying to debug various problems. But this provides a good starting point for users before they create Conda environments and turn those into kernels that they can then use. In terms of lab extensions that we install beyond favorites, recents, and things like that, the Dask Jupyter Lab console is there, although it's very experimental, and we're working with the developers to try to figure out how to make that easy to launch in our batch queue system. One final thing that I want to point out is that at NERSC, when you start up a notebook server, the URL is constructed so that your server has a name. And the name of the server is preset to be a meaningful name that a user can read and understand exactly where they're running. So here's Cori shared node CPU. So that tells me that my server is running on Cori alongside everybody else's notebook server on those login nodes. This also, because this needs to be unique, keeps people from starting up many different notebook servers in the same configuration, which is something that we don't want. But we needed to make named servers work in the user interface, in the Hub user interface, in order to enable this. So that was one of our contributions to Jupyter Hub. Okay, I hope you enjoyed the tour. So this slide is a summary of what our strategy for Jupyter at NERSC is in terms of our activities. I just demonstrated for you Jupyter Hub and Jupyter Lab, what those deployments look like and what we had to do in order to provide that service to our users. Next, I'm going to talk a little bit about what our engagement activities are like. The first point of engagement, of course, always is with our users. Obviously, when they have problems, they contact us, and that tells us a lot about what needs to change in the service going forward. Also, we interact with our users through training events and, of course, email communication, and then, as I showed, through the hub itself. At an experimental user facility level, there are communities of users that want to use Jupyter to streamline their data analysis process for their users. LCLS, NSEM, LSST, these are examples of collaborations that want to be able to do this. And so we have direct engagements with those projects through something called Superfacility, which is a project at NERSC for engaging these kinds of facilities. Also, we have stakeholder engagement that's internal. People in other groups are important to make Jupyter at NERSC a success, particularly in the systems, security, and networking groups. Other staff actually act as Jupyter users at NERSC, and they run training events that depend on Jupyter. So a number of people within the center are invested in the success of Jupyter and are essential to make it successful overall. External to the center and away from our users, interactions with Jupyter developers have been critical to help us at certain points. But also on the HPC side, we do a lot of engagement with people who are also investigating how to set up Jupyter and Jupyter Hub at their HPC center. And we're also interested in engaging more broadly with our vendors, and as they have begun to recognize the importance of Jupyter for our users as well. One of the things that we did in the past year was we participated in the Jupyter Community Workshop series. We held a workshop on high performance computing and user facilities with Jupyter here at Berkeley in partnership with the Berkeley Institute for Data Science. So there are 40 attendees from a number of different types of facilities, from DOE labs. A number of experimental efforts were represented here. The Jupyter Community Workshop series is really great, and it's continuing, and you can expect to see future things around HPC and Jupyter happening through the Community Workshop series. A few comments about what we're going to be doing in the near future. We have a new supercomputer arriving later this year, and so it's going to be fun to get Jupyter working on that. Like I mentioned before, migration to Rancher 2 using Kubernetes, that ought to streamline our deployment. In terms of software development, we're working on single sign-on, federated login, expanding access to compute nodes, environments, and images as a service for users as part of the hub. On the Jupyter Lab notebook side, continuing to make things easier. A binder for HPC is a big deal for a lot of people, and so we're contributing to that. One of the issues we have that's kind of at a pretty high level is educating users on how to take charge of their own Jupyter Lab installation. If we move in that direction, it can be a pretty heavy lift to manage an entire Jupyter Lab installation, especially for a collaboration. So we're going to need to help our users as they get to that point. Innovating on Jupyter is difficult for us in particular, simply because of what the skill set is typically at an HPC center in terms of JavaScript toolkits, which are becoming increasingly important in Jupyter. To finish up, I thought it would be useful to provide a list of things that we've learned through working on Jupyter at NERSC, things that worked well for us and maybe things that were maybe more challenging. Hopefully for people who are in a similar situation, but also for users of HPC centers, so they kind of understand what the challenges are for staff working on this. First thing I'll say is that containers are just an essential thing for managing a Jupyter Hub installation. Using a management and orchestration layer, these things make your life so much better, so you should just do that. Keep a delivery cycle. Maintain productive relationships with your colleagues, your internal stakeholders, other people inside the center that need Jupyter, and be flexible about alternatives when maybe you can't make a change to queue policy, but changing how you do software, a piece of software might work better. Identify and engage with stakeholders wherever they are going to be, inside, outside the center. Focus on what matters to your users, though, first. And of course, rely on the Jupyter community, share code with them, use them to help you retire code so that you don't have to maintain quite so much. In terms of challenges, I'll say at the very top, a successful high-performance computing center management commits to innovation through software development. Management that doesn't do that, I don't think is successful. HPC developers can write Python, but JavaScript, React, TypeScript, that's kind of more rare in terms of a skill set, and that kind of limits how we can directly impact Jupyter Lab. If you're not great at UI design, and you probably aren't, you should probably get help from a UI UX expert when it matters. And I'll just say that resources for making Jupyter work can sometimes be hard to acquire. And so that's a challenge, but again, good relationships with stakeholders can make that a bit easier. Finally, I want to leave you with the thought that, we've had technical problems. We've had the whole thing come down in flames at times, but our users have been very understanding because I think we have a pretty good relationship with them. Keep in mind that technical problems can be challenging, but they're almost always temporary. Here's a slide of links that I thought I'd leave you with, things that I referred to in the talk, but didn't have time to get into in a lot of detail. So I hope you find these useful, and I want to thank you for watching. Enjoy the rest of SciPy.